Hey Chem Kids, Mr. C here, and I want to review all of our nomenclature rules that we learned last semester. First, let's talk about regular ionic nomenclature. So whenever we're going from symbols to words, what we're going to do, the first one, we just write the name of the first symbol unchanged. So like if it's Na, you write sodium. If it's Ba, you write barium. Ca, you write calcium. Mg, you write magnesium. After that, you write the name of the second symbol. If it's an element, change the naming to "ide." So like this case, our example, NaCl, it's sodium is the first thing. The second thing is chlorine, but because it's just an element, we change it to "ide," so it becomes chloride. If it's a polyatomic ion, though, keep it the same. So NaNO3, sodium is the first thing. NO3 is one of those polyatomic ions, so we're just going to leave it as nitrate. So if it ends with just an element, a single element by itself, change the ending to "ide." If it's one of those polyatomic ions, keep the ending the same. Don't change the name. Going from words to symbols. So the first thing you're going to do is write the name of the first symbol, and then you're going to write the name of the second symbol or polyatomic ion. So like we have barium chloride for an example here. Barium is Ba and chlorine is Cl. So that's easy. We just look up those things. Remember, if it ends in "ide, it's referring to the element. Chloride is chlorine. Bromide is bromine. Fluoride is fluorine. The next thing we gotta do is we gotta cross the charges. So the charge on the first thing becomes a subscript on the second thing, and the charge on the second thing goes to the first thing. So like barium has a +2 charge and chlorine has a -1. Well, the 2 comes down to chlorine and the 1 goes down to barium. So it becomes BaCl2. And remember, we don't care about the plus or minus sign. So we're just flip-flopping those charges here. Whenever we have sodium sulfate, it's NaSO4. Sulfate's -2, sodium's +1. The 1 goes to sodium, or sulfate, sorry, and the 2 goes to sodium. So it becomes Na2. SO4 there. So it's the same with polyatomic ions. If you do have a subscript that goes on a polyatomic ion, you will want to put it in parentheses. The next one, special ionic nomenclature. Writing or going from symbols to words is pretty much the same thing, but there is a little bit more that we have to do. So we got to write the name of the first thing. Then we have to determine the Roman numeral. So like this first one, we have FeO. FeO. So Fe is iron. So we're FeO. But now we have to determine what our Roman numeral is, and the Roman numeral will be equal to the number of nonmetals. So in FeO, we have one nonmetal because we have one oxygen, times the charge of the nonmetal. Well, the charge of oxygen is 2. Really, it's -2, but I don't care if it's plus or minus. Divided by the number of metals. So we have 1 iron. When we plug that all in, we get 2. So we're going to put a Roman numeral 2 behind that. And then we get to the second thing, once again, similar to our other rules. If it ends in just an element, so like this ends in just oxygen, you change the ending to "ide," so oxide. If it ends in a polyatomic ion, you don't change anything. So here we have CuOH. If we're doing our formula, the charge of OH as a whole, or sorry, the number of OHs, we have 1 OH. For the charge of OH is 1 divided by the number of metals, which is 1. So we get 1. So this would be copper 1 hydroxide. Would be our answer for that. So you do have to use this. 90% of the time, the subscript or the Roman numeral is whatever the subscript is after the polyatomic ion or after the nonmetal, but this is not always the case. So you do want to double check real quickly with that formula there. Going from words to symbols, it's just like the other ionic nomenclature. So write the symbol of the first element, write the symbol of our second element, so like copper chloride, CuCl. We got to cross the charges. The charge of the first thing is the Roman numeral. So because it's copper 1, the charge of this copper is +1. The charge of chlorine is -1. We flip them, it becomes CuCl. We have zinc and then nitrate. Because it's zinc 2, the charge of zinc is +2, nitrate -1. We cross those charges, so this becomes Zn, NO3, 2. So not too bad. The words to symbols on these are the same. The only difference between ionic and special ionic is we got to figure out what that Roman numeral is going to be. Next, we have covalent nomenclature. So for covalent nomenclature, going from symbols to words, we want to write the name of the first thing, and we want to include the prefix if its subscript is greater than 1. So like in this first example, carbon monoxide or CO, because there's only a 1 on the C, we're just going to write it as carbon. But in P4O, we have to write it as tetraphosphorus, not just phosphorus. But the first thing just stays the same. Then we want to write the name of our second thing with the prefix no matter what, and the ending will always change to I. So in this one we have CO, carbon, O is oxygen, but because there's a 1 there, we have to put that mono prefix in front of it, so it becomes monoxide, and we change the ending to I. So P4O, tetraphosphorus, because we got to include the prefix plus the element name. And then the second thing, we change the ending to "ide," so it's oxide with the prefix in front of it. So it'd be tetraphosphorus monoxide. Not too bad. Going from words to symbols, you write the symbol of the first thing, and the prefix becomes the subscript. And then you write the symbol of the second thing, where once again the prefix becomes the subscript. So carbon dioxide, no prefix on that first thing means 1, so it's just C. Oxygen or oxide is just O, and because there's a di in front of it, you put a 2 there. For disulfur trioxide, sulfur is S. We have di in front, so we put a 2. Oxide is O. We have a tri in front. We would put a 3. So not too bad. The hardest part with this is you do have to memorize this table here. But a lot of them are like mono's 1, that's easy. Di, tri, easy. Tetra is a little bit easy to forget. Penta's easy. Hexa is easy. Hepta people forget. Octa, that's not bad. Deca is not bad. And nona. So like I would say that like 4, 7, and 9 are the ones people forget the most. And then our last type of nomenclature here, acid nomenclature. Symbols to words, there's 2 types. If it's hydrogen and an element, you're going to fill in the blank here. It becomes hydro, the element name, change the ending to ic, and then acid. HCl, hydro, because it's a hydrogen plus an element. Cl is chlorine, but we change the ending to ic, so it becomes hydrochloric, and then acid. HF, hydro, because it's hydrogen in an element. F is fluorine, so it becomes fluoric, so hydrofluoric, and then acid. So not too bad there. The next one, if it's hydrogen plus a polyatomic ion, we're going to fill in the blank here. So the name of the polyatomic ion, that's supposed to say ion, and then acid. We do have to change the ending though. So if the polyatomic ion ends in 8, you change it to ic. If it ends in ite, you change it to OUS. So HNO3, because it's a polyatomic ion there, we're just going to start off with the name. So NO3 equal to nitrate, but 8 will go to ic. So instead of becoming nitrate, it becomes nitric acid there. NO2, on the other hand, is nitrite. We have H and a polyatomic ion, so we change the ending to OUS, so this becomes nitrous acid. Not too bad there. So 8 will go to ic, and ite goes to OUS. You ate it, and it was icky, and then the other one's just got to be us. I don't have a good memorization one for that. And last but not least, going from words to symbols. If it starts with hydro, so like hydro something acid, you start by writing an H, and then you write the element symbol there. I don't know what the heck that is for. Hydrochloric acid, HCl. Hydroidoic acid, HI. Chloric is Cl, so we put a chlorine, so that's Cl. Idoic, iodine, we put the I. The last step, that's what this should say, is cross the charges. So in this case, hydrogen is a +1, chlorine is a -1, so it just becomes HCl, and the same with HI. But say you had like hydrosulfuric acid. For hydrosulfuric acid, it's H with a +1, S -2, so it become H2S, and that's going to be the third step over here as well. It does not start with hydro, sulfuric acid, sulfurous acid, nitric acid, nitrous acid, something like that. No hydro in front of it. You still started off with an H, but then we want to write the polyatomic ion. If it ends in ic, choose the polyatomic with 8. If it ends in OUS, choose the polyatomic with ite. Sulfuric acid, it doesn't start with hydro, we write that. Oh boy. We'll go back up. Oh, so we start with H, which has that +1 charge, as we do have to cross the charges. Sulfuric, either referring to sulfate or sulfite. It ends in ic, so it's sulfate, so it's SO4 with the -2. Cross those charges, we get H2SO4. Sulfurous acid, we start with that H. Sulfurous, sulfur, it's talking about sulfate or sulfite. It ends in OUS, so it's sulfite, so it's SO3 -2. Cross the charges, and you get H2. So 3 is your answer. We will be having quizzes over this all semester, so you might want to periodically just kind of go through this PowerPoint if you need help with nomenclature.